Oxidation and Reduction. Hi everyone! Have you ever thought about why things rust or tarnish, such as the zinc on your roof or even the chain on your bicycle? This all happens through a redox reaction known as oxidation and reduction. Oxidation is the gain of oxygen and reduction is the loss of oxygen. These two reactions go hand in hand. You can easily remember this by using the numeric oil rig. Let's dive into it for a clearer understanding.
Rules for assigning oxidation number. Rule number 1. The oxidation number of a simple ion is equal to its ionic charge. For instance, if you have gold with a charge of positive 2, then the oxidation number is equal to positive 2. Rule number 2. The oxidation number of hydrogen is always positive 1, except in metal hydrides where it is negative 1. Examples for these would be hydrochloric acid, where the charge would be positive 1, and sodium hydride, where the charge would be negative 1. Rule number 3. The oxidation number of uncombined element is always 0. Rule number 4. For any neutral or zero charge compound, the sum of the oxidation number is always 0. An example for this would be CO2, where there is no charge, so the sum of the oxidation number would add up to 0. Rule number 5. For a polyatomic ion, the sum of the oxidation number is equal to the charge of the complex ion. An example for this would be dichromate, where the charge is negative 2, meaning that the sum of the oxidation number would equal to negative 2. Rule number 6. The oxidation number of oxygen is always negative 2, except in peroxide, where it is always negative 1, since peroxide have one more oxygen than the normal oxide. Rule number 7. All halogens have an oxidation number of negative 1. And finally, rule number 8. Anything in group 1 is positive 1, and anything in group 2 is positive 2. Some examples for these would be lithium, potassium, sodium, anything in group 1 or 2.
Oxidizing agents gains electrons, but in a chemical reaction it loses electrons, whereas reducing agents are what loses electrons but gains electrons in a chemical reaction. Oxidizing agents, or OA, can also be referred to as an electron acceptor, while the RA can be known as the electron donator. Some examples of OA are halogens, peroxide, oxygen, and nitric acid. Some examples of RA are ammonia, carbon monoxide, sulfite compounds, and earth metals. Having said that, solving redox equation is somewhat difficult. How should it be solved?
Hi everyone. I can understand that the most common mistake about oxidation and reduction problem is within a redox equation. But don't worry, we will fix that problem today. We will start by practicing with a simple question. We have 2 potassium permanganate plus 5 potassium nitrite plus hydrogen sulfate gives us 2 manganese sulfate plus 3 water plus 5 potassium nitrate plus potassium 2 sulfate. A lot of you are confused with what to do with the balancing ratio, but don't worry, because you don't need to do anything with them. Again, we identified the compound or element to one of the oxidation rules. We can see all the compound on the reactant side is neutral, so the sum needs to be 0. So potassium plus 1, manganese plus 7, oxygen 4 minus 2, potassium plus 1, nitrogen plus 3, oxygen 2 minus 2, hydrogen 2 plus 1, sulfate plus 6, oxygen 4 minus 2, all equals 0. The same can be said for the product side. So manganese plus 2, sulfur plus 6, oxygen 4 minus 2, hydrogen 2 plus 1, oxygen minus 2, potassium plus 1, nitrogen plus 5, oxygen 3 minus 2, potassium 2 plus 1, sulfur plus 6, oxygen 4 minus 2. The most noticeable is nitrogen, from losing plus 3 electrons to losing plus 5. So it is oxidized due to an increase in the oxidation state. Remember that the opposite of oxidize is a reducing agent, especially from the reactant side, for it to be the answer. So it is 5K NO2. Also, you can see a huge change from manganese losing plus 7 electron on the reactant side to losing only plus 2 electron on the product side. So it is a reduction since it decreased in oxidation state. And the opposite of reduction is oxidizing agent from the reactant side, so it is 2KMnO4. Please pause the video right now and practice these questions by yourself, then resume back to see if you got the correct answers.